I've seen the same story play out over and over. You spot a budget LiDAR sensor on a forum, think you've scored a steal, ship it home, and end up wrestling with spotty returns, mismatched data, and a whole lot of wasted time. That regret is the exact reason I paused before I even pulled the Livox Avia out of the box. Link is in the description if you want to check the product details on Amazon. The question isn't just does it work, but does it actually make my drone mapping workflow smoother, or am I swapping one headache for another? When you're building a 3D map of a construction site or trying to get a robot to navigate a cluttered warehouse, the sensor you choose becomes the backbone of the entire operation. I spent the last week setting up the Avia on a quadcopter, running it through a series of indoor obstacle courses, and then testing it on an outdoor survey of a small park. What stood out wasn't just the raw detection range, though that's impressive, but how the sensor behaved when the real world got messy, leaves swirling in the wind, reflective glass, and sudden changes in lighting. First off, the Avia's dual scanning modes felt like a practical compromise between speed and detail. In continuous scanned mode, the sensor delivered a steady stream of points that kept my autonomous navigation algorithm from missing a single pole in the indoor maze. Switching to the higher resolution burst mode gave me a denser point cloud, which was crucial when I needed centimeter-level accuracy for the park's topographic model. The ability to flip between those modes on the fly saved me from having to carry two separate LiDAR units, and it let me balance battery life against data quality in a way that cheaper, single-mode sensors simply don't offer. The built-in IMU was another surprise. Many entry-level LiDAR units expect you to pair them with an external inertial measurement system, which adds weight, cost, and another point of failure. The Avia's integrated IMU handled the synchronization internally, so the point cloud stayed tightly aligned with the drone's pose even when I performed sudden yaw rotations. In practice, that meant I could trust the generated maps without spending hours in post-processing to correct drift. For anyone who's been burned by misaligned datasets, that internal precision is a tangible time-saver. That said, the Avia isn't a magic bullet. Its ultra-lightweight claim translates to a sensor that sits at just under 200 grams, which is great for smaller UAVs, but the trade-off shows up in the power budget. On a 4S LiPo, the Avia pulled enough current that I noticed a 5-minute dip in flight time compared to a configuration without any LiDAR at all. If you're already operating near the edge of your drone's endurance, you'll need to account for that extra draw. It's not a deal-breaker, but it's a hidden cost that can catch you off guard if you're budgeting flight minutes tightly. Another practical nuance is the triple return technology. In theory, getting 3 returns per laser pulse helps you see through foliage or semi-transparent surfaces, and in my outdoor test it did capture the canopy under a few trees, giving a more complete ground surface. However, the software that processes those extra returns can become a bottleneck on less powerful onboard computers. When I tried to run the full point cloud processing on a Raspberry Pi 4, the frame rate dropped noticeably, and I had to offload the data to a ground station for real-time analysis. If your setup already pushes the limits of its compute hardware, you may need to consider whether you truly need every return or if a single return mode would keep the pipeline smoother. The open-source ecosystem surrounding the Livox line is arguably its strongest selling point. The SDK is well documented, and there's a growing community contributing drivers for ROS, PX4, and even custom Python scripts. I didn't have to reinvent the wheel to get the Avia talking to my SLAM stack. A few lines of code pulled the sensor data straight into the map builder I was already using. For developers and researchers who want to tinker, that openness translates into weeks of work shaved off the integration timeline. On the flip side, if you're a hobbyist looking for a plug-and-play experience with a proprietary app, the lack of a dedicated one-click configuration tool could feel a bit raw. Who should actually consider buying the Livox Avia? If you're a robotics engineer, a surveyor, or a drone mapping professional who needs a lightweight sensor that can toggle between fast, coarse scans and dense, high-resolution captures, the Avia ticks the right boxes. Its built-in IMU and triple return capability add robustness that cheap alternatives lack, and the open-source support means you won't be locked into a black box workflow. In contrast, if you're a casual hobbyist who just wants a quick 3D snapshot and you're already comfortable with a basic 2D LiDAR, the Avia's extra features and power draw may feel like overkill. You'd likely be better off with a simpler, lower-cost sensor that plugs straight into a hobby flight controller without the need for extra software layers. In terms of durability, the